everybody. Welcome to the first episode of Axioms on Trial. I will say that right this time instead of spelling it wrong like I have been doing in a lot of the promotional stuff that I've been working on. But anyway, I am Mike. You will see regularly here with me. We know him in the debate. You might actually have seen some stuff potentially if you're in the circles of our debate scene. He goes by Cease to Know. How are you doing today, bud?
Good. I'm glad to be here. I'm excited for this. It's been a while coming. So
Yeah, I know it'll be fun. First off, I actually just want to extend everybody who is watching this now that you could literally be anywhere else in the world and you're choosing to spend time here, and so we definitely appreciate that. So that we don't want that to go unnoticed. But the typical gist of what we will be doing, which Cease can touch on as well, but basically just anything in the realm of philosophy, theology, science, anything in that realm, we want to have an honest and open discussion. We want to provide a spot that's going to really, I guess let's put it this way, we're going to attack the beliefs. We're not going to attack the person, but we are going to attack the beliefs. If it doesn't hold up, we don't have any problem in someone having that on their end, and hopefully on our end they shouldn't feel the same. So, or they should feel the same. So with that said, what do you want to present for the show?
I think we had talked about the plan here is we want to create an environment where theists can come on and feel comfortable sharing their testimony, but also I want to be able to challenge their beliefs. I want to have be able to have a dialogue, and I want to put pressure on what their certainties are. And so what we plan to do is have discussions with atheists, theists, philosophers of different kinds. I would like to host debates as often as we can, do video breakdowns of arguments, where the flaws in the arguments lie, share some interesting philosophical ideas that we may have encountered. So we're going to be doing a variety of different things, and hopefully you guys will enjoy it.
Yeah, I think the main thing that we'll really touch on is a lot of breaking down arguments whenever we don't have a guest. So we'll have a good amount of shows in between having the guests and things like that where we can spend time if someone wants to come on and break down arguments with us or say where we went wrong. I think that opens up a pretty cool forum for all sorts of things that we can do. So we'll feel it out and it'll go well, I think.
One aspect in particular that I'm going to want to pay attention to is taking apart the arguments of the apologists, because I have the biggest gripe with them, because I feel like their approach is sort of modern day sophistry. It sort of makes a mockery out of what I think philosophy is, and so I have a real problem with that, and that's something that I want to tackle in what we're doing.
Yeah. 100%. I think I think especially you with, well, at least how I'd like to get this is those one-on-one conversations with you and somebody of that caliber is just going to be a beneficial conversation for more than just you and that person. I think for a lot of other people. So I'm really excited almost for as myself to witness that because I definitely hold you in high regards in that realm. I'm just scratching the surface in philosophy, but I definitely I definitely. I don't feel like it takes a very high level to be able to pinpoint where these arguments go south quick. I think it's pretty basic, and so hopefully we can touch on that with philosophers or theologians or. I've been trying to get Matt Slick on the show, so if we can get him on, I think that'd be pretty cool. I think that'd be a pretty cool thing to have because I definitely have some problems with his arguments. But
for sure.
That said, let's get to the meat of the conversation and introduce David. How we had a conversation on the Atheist Roundtable last time, so we had a pretty I think it was pretty productive in the science realm of things. Are you ready for more taking that to a new level in a sense?
I'm not sure I can take it to a new level, but maybe the same level.
Yeah. Well, and actually I'll start that off there, is that some people seem to take it to another level. They seem to take, and what I mean, for the viewers, I'm kind of just going ahead of myself, is in regards of quantum mechanics or quantum physics. It seems people just kind of get this. This fits what I already believe, and I can use it advantageously for my agenda of that belief, or whatever it might be. Like, what do you think of that? That could be a theist side, atheist side, whatever, political somehow. I don't know, any type of way that someone would use it. Like, how do you think? How do you think of that when somebody
Yeah.
uses it that way?
I think the question you want to ask yourself is, are you trying to impose on the world some idea that you want to be true, or is your idea coming from the world, from looking at the world in some way?
Mm.
I think I sort of divide things up in that way, and try to analyze it like that.
Yeah.
So I think a lot of the arguments that you're talking about sort of end up in that space where people, especially when it comes to quantum physics, they like what they've heard in the past, and then they put the science away because they're happy with what they've seen, but they haven't looked very deep to realize that what they're doing with it doesn't really work, and they want it to work in their service. But that sort of strikes me as trying to take what you want to be true and then taking aspects of science that you haven't really looked at in any detail and using them, and then not paying attention when it turns out that it didn't quite work out that way.
Yeah. And you have that background. Would you share that the background, at least, that you have in regards to science?
Oh, sure. I've been interested in science for as long as I can remember. I'm originally from Italy, and I started at the university in Bologna. I transferred to the United States. I've been to many different schools, actually, both as a student and as a teacher. So I've seen a lot of what goes on in universities, both as a student and as a instructor, professor, and so on.
Yeah.
And eventually I settled on astrophysics, in particular black holes, and that's what I'm doing my research on. I happen to be teaching the quantum physics course this semester. This is the third time that I teach it. So you always try to find something, some new angle on things, and try to go a little bit deeper. You want to use your experience teaching to learn something deeper for yourself as well, and then maybe that helps you express the concepts a little bit better. So I
Sure.
always enjoy teaching quantum physics.
Sure. And I'm going to tee this off to Cease here. I kind of would be interested on you guys having a conversation in regards to. Uh, I guess I would just break down this as what I think is somebody that might take uh, something in quantum physics, for their belief, in a sense. Like, what do you think about the idea that if within quantum physics, some people say it shows that life would be inherently not deterministic, uh, which would, have, some people would at least allude to that being that it basically kills determinism. I'd be interested on what you both kind of think of that.
So I think this is a space of misconceptions. When you look at the theory, it's completely deterministic. There, again, last time we talked a little bit about these so-called different versions of the theory. They all predict the same experimental results, but there are different versions or different interpretations, if you want. But I think it's fair to say that it's hard to sort of describe the extent to which these ideas are deterministic, because you're not dealing with mathematical expressions and their meanings. So if I were to give you a mathematical quantity, that quantity comes from some specific mathematical place, and you solve an equation, you get a solution, and there's no guessing associated with it. And so I think there's a lot of misconception about what that even means.
Sure.
And it's difficult to get the idea across because it's difficult to convey the idea that these prescriptions are mathematical. That seems like an abstract kind of thing.
Yeah.
We've discovered this strange feature of the world, which is that it obeys mathematical rules, but it takes years for people to see that when you're asking a question about the theory, for example, I'm also teaching electricity and magnetism, and I have my students who ask a question, and I say to them, well, why are you looking away from your mathematical structures? You have your mathematical equations there. You've seen some of the solutions. You've explored them. Everything that you need to know is there. There's nothing beyond that you then impose on this, right? And so it's kind of an abstract idea, but it takes years of practice. I remember this as a student, to go from asking for something about the theory somewhere else and not paying attention to my equations. All the answers are there. That's what the theory is about. It's a very specific kind of thing. Everything is connected to everything else in the mathematics of the theory. And so some people, in fact, will say they don't want to give me explanations about things, very abstract things. Like when I was trying to learn general relativity, they would say, look, just look at the math. Stop asking these questions. Stop asking for words. It's there in the math. That's the real thing. I can give you some words, but those words are probably not going to be so useful. The real thing is in the math. And, that's not something that human beings warm up to. I wasn't happy when I heard that kind of thing. I needed some kind of description in words. That's how human beings are. So
I do want to ask a question about that, because I think in the philosophy realm, there's a lot of people that would question the degree to which mathematics can be said to capture the world in the way in which you've described. Now, I'm not saying that I agree with them. In fact, I probably don't. But the belief is there, and it's the idea that even any measurements that we've chosen, why couldn't it not have been otherwise? Why is it not arbitrary?
Sorry, why wasn't? Why what isn't arbitrary? What is arbitrary?
The measurements that we choose, the mathematics that we're using, why could it not be otherwise? Instead of, for example, being what we call a meter, could be any other unit of any other number, and then the math will look different. I'm not saying that I agree with this, but I'm just wondering how you would respond to that type of approach. That math doesn't capture reality.
It's very difficult for me to understand the meaning of this kind of idea, because, for example, I can give you in the electricity and magnetism course, we start to imagine experiments. We're playing around with charged particles, and we start to notice, as we move these charged particles around, this is sort of the lecture that I give, we start to notice that certain things happen. You're holding a charged particle here, and there's a charged particle over here, and you feel a force on your hand because the charged particle feels a force, an electric force that we end up calling it, from the other particle. And then if you bring it closer, you feel that force is larger, and you start to build up a mathematical relationship. And then you play around with other quantities that we call magnetism. And then little by little, you come up with these mathematical descriptions that come from experiments that know nothing about things like light. And then you play around with this math, and eventually you get to a point, right? This is where we end up at the end of the course. We end up at a point where you have solutions to mathematical relationships that are not things that you put in by hand. You don't have choices, right? You play around with this math, and basically what it says is that in places where you don't have charges and currents, but charges and currents are somewhere else, and charges and currents over there are moving around, and they're accelerating, and the math tells you that what you get where you are light waves coming to you as a result of this. It comes out of the math. And so, this is what Maxwell did in the 1880s or so, maybe a little bit before, actually. I think in the 1880s, people were starting to think, well, let's do experiments. Let's see if that's in fact the case. And that's how our modern technology emerged, right? We take advantage of light or electromagnetic waves in general. And so, I would say, well, okay, so if it's true that you can explain electric and magnetic phenomena, this is a huge amount of data. explain all of these experiments in a completely different way with other equations that then don't lead to electromagnetic waves, or that do lead to electromagnetic waves. If they don't lead to electromagnetic waves, then the theory somehow doesn't work. It's not explaining nature. So I don't see, I mean, that seems like a statement out of the blue. You know, we can imagine some theories, some mathematics that's going to explain all of our experiments in a completely different way. And it's also going to explain, it's going to have solutions in these equations that, you know, we discovered later on. And they're going to be, it's a completely different theory, but not it explains everything that you've seen before. You have to show me that, you know. So that's a tall order. So I have trouble with that kind of thing.
Sure.
So what you would say is that math is discovered, not constructed.
These are relationships that are discovered, exactly. I mean, what you can then discover later is that math wasn't quite right. You put it together, you know, you were doing the experiment in your laboratory, then you realize that it needs to be generalized. We've seen that kind of thing happen. But we don't come in and impose. It's very hard for you to come in and impose some mathematical relationship that you've invented and then find that it explains all of the experiments that we've done in some subdiscipline of science.
Okay.
Gotcha.
Yeah, that because I see that a lot, at least a lot in debates I see where you have someone kind of arguing the abstract nature of numbers or linguistics and these kind of things, and I think it gets real sticky because you get into this kind of prescriptive versus a descriptive thing, especially when you get into like law of identity, non-contradiction, excluded middle, where you got these, you know, like this is a thing as opposed to like, well, this is how we are applying logic to reality. I mean, I always kind of equate it as a programmer to machine language, and then using a high level language like Java that we use to just make sense of zeros and ones, like the reality of the machine language. I don't think it translates, I guess, for a lot of people if they're not familiar with that, but I kind of want to touch on that more. Do you think the language that's used within for perhaps quantum physics, or whether it's like the observer effect, for example, you know, I think people conflate this like conscious being kind of thing, where maybe the language is dancing or they're doing what it wants. I mean, what do you think?
Yeah, so I think you're sort of suggesting that some people will criticize science based on the idea that maybe the ideas that are there are not completely or fully well defined. Things need to have a very specified kind of identity for them to be meaningful.
I guess more so like the manipulation that's used in terms of. So I guess I would use the observer effect as an example where you people are saying it's
Okay, so you're
because
just using
well it's
something
like
scientific in a way that's not intended to be used
well yeah it's
in
like
the field.
well I guess that's my is like there's would you say there's a hard line difference between that and math, like math it's concrete in that you're not going to, if you know you allude to the equations, you're going to get the right conclusion out of that. Like are you still privy to essentially having the same kind of product you have with linguistics where you can kind of do what you want with it to rival a conclusion?
I think it's important to have a conversation in words. I mean, my intuitions are not mathematical. So when I come up with an idea,
Yeah,
it's some kind of it comes from some place that it doesn't matter where it comes from, right? But what matters ultimately is that I can translate it into some mathematical form that then sort of lives on its own. I don't have a problem with using words to describe things, and I don't think it's really a problem that the words we use are not perfectly well defined.
sure.
Um, we mentioned this last time. The physics is basically the subject that deals with space-time and matter, but now we're starting to realize, well, we've been realizing this slowly, but that these quantities are not what we thought they were. They're not really fundamental, and there's something else there. But so we weren't really very precise about what we meant with these things, and they certainly weren't what we thought. They weren't fundamental quantities of the universe, but none of that really stopped us from getting at truth at some level. So in other words, the physical world reduces to a description in terms of space, time, and matter, and we don't really know exactly what these things are, but that's good enough. It doesn't have to be perfectly well defined.
Sure.
But there's a big difference between taking these things and having them mean whatever we want, right? And then just inventing meanings of things and bringing in terms like the observer effect when we've understood that. But that's something that we've understood isn't a thing. We can explain what's going on there. It's been years that people have been dealing with this subfield of
Sure.
physics that deals with that, and that's not a thing in quantum physics anymore. So
that's one battle that I keep having with religious people in my conversations and debates, is where they think that if we can't have certainty, that everything just crumbles, that everything just becomes relative, and we have no way of grounding any kind of notion of truth. And it's like, no, we can still observe patterns and get at some kind of reasonable understanding of the way things are, even if we can't have absolute knowledge.
absolutely.
And they can't grasp this concept.
Yeah, it's just fallibilism and philosophy. I mean, right? Just the idea you don't have to have absolute knowledge. Essentially,
you can notice a rigorous pattern of some sort that you then try to describe in words. And you realize there's a mathematical structure. In quantum physics is like that.
Yep.
I teach the students things that ultimately seem to violate logic, and we get along just fine with the predictions, and in fact they're matched. There are issues there that need to be resolved, but this precision thing ultimately doesn't need to be 100%. We have to have some sense of what we mean by space, some sense of what we mean by time, and some sense of what we mean by matter to do most of physics. But we don't really know what time is, right? Define time.
Do you say it violates logic, or is it seems to, and then you can come?
Yeah, let's say that it seems to, right?
Okay. Yeah. So you would still say if it like violated, say, I don't know, like I don't know. I think I've heard, and I could be so wrong about this, but I've heard something about how the electron produces like an electron cloud around the nucleus, so it essentially could basically be like at one place at one time and not at one place at one time, or something along those lines. So it would essentially violate non-contradiction or identity.
Right. So the mathematical description of the electron is that it's the mathematical object has all of the positions that the electron could be found at in the mathematical description.
Yeah. Okay. Yeah.
What does that mean, right?
Yeah. Well, I was gonna say, does that make you like, you think it's just that the conclusions being drawn that's happening all at one time? All right, because that's where I get lost. That's what I just don't understand, at least because I just see people make the conclusion, but I'm sitting here going, I still don't even fully get how you can draw the conclusion when it seems that we have so many interpretations of.
How do we draw the conclusion that the electron is everywhere at one moment?
Yeah, well, that it would be violating logic, or at least what we've devised as, these laws of thought.
So the idea that the electron is at many different places at once, right? That seems to violate logic.
Sure.
But when you do the experiment, you'll find it at one location. But if you assume that the electron was actually at the location where you found it, then you'll end up not getting the right result from the theory. So you can't assume that the electron is at a specific location. In fact, it has to be everywhere before you observe it. And when you observe it, you end up observing it at a specific location. But you'll get the right result only if you assume that all of the information is in this mathematical object that has all of the possible positions in it.
So that's a problem, I think, philosophically speaking, as to what that could mean in reality.
Right. So again, there are different interpretations here, or different versions.
Right.
Maybe versions is the better. description, but there's a perfectly rational, much more economical version of the theory, which gets past these strange features. And of course, it has this high price to pay because it's basically saying that there are multiple particles. That's why the mathematical object has multiple positions, because there are multiple particles in the theory, and the results of the experiments are the results of multiple kinds of objects interacting with each other.
I think you mentioned this last time to some degree. You were talking about this.
Yeah.
Mike, I have a set of questions I'd like to ask.
Sure. Of course.
Yeah. But you can go. I mean, you can go first.
No, I'd love to listen.
So the one thing that I run into a lot is, religious people basically making the accusation that, I mean, I know what you're going to say, but just for the sake of argument, that it takes more faith to believe in something like the Big Bang and microevolution, and that it takes more faith to believe that everything evolved randomly to be what it is now than to believe in God or any of that stuff. So how would you respond to that kind of approach? There's people who don't think that there's any evidence for the Big Bang or any evidence for microevolution, that these are just, people misuse the word theory. I would just like to get your...
Okay. I mean, this is a massive misconception, right? So to say that a theory doesn't have any evidence in its support is a non-trivial point of confusion. I mean, so theories are the most important thing in science. And so any theory has so much evidence in support of it, right? That doesn't mean that it's true, but that at some level it's capturing reality. Right? To say there's no evidence in favor of a theory, like say the Big Bang, right? So why did people subscribe to the Big Bang theory? Because the evidence forced them to. It's very strange because you hear this from religious people. It was the religious people who jumped with joy when they saw the first bits of evidence emerge for the Big Bang theory.
Right, that's
right?
the irony.
That's the irony. Now, for some reason, it seems to be a point of contention. But so, I mean, how deep do you want to go? There's the simple initial observation in the 1920s, which I have my students think about this in my general astronomy course, and it's looking at galaxies that are sufficiently far away in completely opposite directions of the sky. So you imagine looking in the southern hemisphere, and you're looking at, hundreds of millions of light years away, and you see a galaxy. And then you look at another galaxy in the northern hemisphere, the complete opposite direction, right? 180 degrees in the opposite direction. And at the same distance, you find another galaxy at the same distance, and these objects are moving away from us at the exact same speed. Now, there's some subtlety there. It's really better to talk about redshifts. They initially thought about these things as speeds. So you get a picture of, eventually they started to build up a picture of galaxies, very distant galaxies, that are moving away from us faster the further away they are from us, in any direction you look on the sky. Now, it takes an hour or two to think about this, but the most natural thing to do is to try to explain this as things moving away in space from us. But that's a huge fine-tuning issue, right? Think of it as an explosion. It's very hard to explain this kind of thing. It has to be some perfectly fine-tuned kind of agreement between these galaxies for them to be moving in this way. Explosion, things move away fast, closer in, and then they start to move away slower as they're further away. But of course, it's completely messy. right? So these things are moving in such a way that you can describe them very nicely as if you had a balloon. You put these objects on a balloon, you draw them on a balloon, blow up the balloon, and you'll see that all objects that are further away from some point on the balloon is moving away faster in a way that depends on how far the object is. And so this is evidence that the best way to explain this is that this is expansion of space. And what's the current theory? Well, in the mid-1920s, some Russian guy came up with a solution to the equations of general relativity and showed that expansion of space is a solution to these equations. And so you have theory and you have observations coming together. And so the question is, okay, try to explain it. Ask someone who doesn't believe in the Big Bang Theory to explain the set of observations, the Hubble diagram, the speed of distant galaxies as a function of distance. Right? The further away they are, the faster they're moving. I mean, how are you going to do that? I mean, that's a massive amount of evidence there that you need to explain, and you can't just dismiss it like that.
It comes from it comes from a complete misunderstanding of how the science works. They think,
Right.
oh well, we can't go back that far to see it happen. Therefore, we have no evidence. It's just pure ignorance. There's no understanding what.
Okay, but then you're talking about how you gather evidence, right? And we can have that's an entirely different conversation. But if you want to deny, every move that one makes, of course, then you never get anywhere. But that's not the conversation that you want to have. You want to have someone who's open-minded, who agrees with good ideas. And our instruments, when we're dealing with things that are far away or very small, it's a little counterintuitive. You have to get some degree of expertise. Of course, when you ask a scientist, by 1929, by 1930, did they believe in the Big Bang? Most people said no. Did they try to explain this data? Most people, because they're normal people, they don't have that much imagination, so they didn't even try. But that evidence wasn't enough to convince them of the Big Bang. Most people didn't believe in it. Some people came up with some other ideas of how this could be explained. And it took another 40 years before solid evidence emerged for the Big Bang Theory. And everyone said, it's got to be the Big Bang. It can't be these other ideas. Right? So you play around with the math again, and you get this clear prediction that everywhere on the sky, wherever you look at, you should have some radiation, electromagnetic waves, again, Maxwell's equations, coming to us from every point on the sky that correspond to stuff at a very, very low temperature. And that's a very precise statement. Everywhere you look on the sky, you should see this. In 1964, you saw the first evidence of this. Everywhere these people looked in the sky, these weren't even scientists, they were engineers looking for something else. They were dealing with telecommunication, and they found this hiss everywhere. It's the same everywhere. How do we get rid of it? They started shooting pigeons because they couldn't figure out what this was. And eventually they realized this is the afterglow of the Big Bang, right? And so try to explain that. And then we can go further, right? But these are just some pieces of evidence. So to say that there's no evidence for the Big Bang, that's not an interesting conversation to have.
It's frustrating when you hear someone say, microevolution isn't real, and then they can't even differentiate between evolution and biogenesis. Like, well, where did the first organism start? As though that's a problem.
The conversation suddenly just changes.
Right. It's not even being aware of what the theories are even saying. It's just pure confusion at every turn, matched with severe arrogance. It's one of the reasons why I'm doing this right now is because I'm so fed up with running into people like that I sort of want to clarify.
You want to have a conversation with someone. You want to say, listen, you need to be in good faith if you want to have a conversation about whether these ideas are true or not, to the extent to which they may not be true. Right. So it's strange that it's trying to impose what you want the world to be like instead of looking at what seems to emerge as true from the world. Right. So the evidence, the data, whether it's Big Bang or biology, biological evolution, right? The fossil record. Why are they distributed in the way they are? Why does carbon dating, it's some technique that comes from physics, give timescales that are completely compatible with the theory of evolution, right?
What
And
a
then
coincidence.
genetics comes along and confirms that pattern. You can't just
Yeah.
dismiss that. That's not an interesting conversation to have.
Right. You mentioned fine tuning, and I just wanted to get your response to the argument that the fine tuning is evidence for God, and that every organized system we've come into contact with has had intention behind it. So when we see order in the universe, why is it not reasonable to assume that order was put in place by something?
Okay, so I mean, we can make statements that seem reasonable about the world, right? So, like you should be free to have intuitions, come up with good ideas or ideas that you think are good, and then let's go out and see whether or not they're actually good, right? So, one of the things that we've learned, again, back to this basic picture of physics, which is matter moving around in space as time goes by. And what have we discovered? That ultimately there's something there that's not fundamental or that's ultimately wrong about what we think these things are. And so that's completely counterintuitive to us, right? So from the perspective of biological evolution, right, the theory makes a prediction about our brains, the kinds of things that we should come up with. But we should come up with things, ideas that seem reasonable to brains that develop in a certain kind of environment. Like no brain is going to have an intuition about quantum physics. In fact, nobody came up with quantum physics. Right? No brain is going to came up with ideas about relativity, curved space-time. Right? These are not intuitive ideas. So we should the prediction of biological evolution is that we should come up with ideas that are compatible with what's called classical physics, which is intuitive, right?
And the counterintuitive was driven by the experiments
Right, and the
the world.
counterintuitive, we get to the counterintuitive. We can get behind these biases that we have, right? You could imagine brains that are just not capable of doing that. They emerge and they think certain things are intuitive and they don't go anywhere beyond that, and they just can't handle anything. But we've been able to get around that lack of intuition. But the lesson here that I think we should learn is that we should be careful with this intuition. Just because you think an idea is good doesn't mean that it is. In fact, it means it's probably unlikely to be true in any way. So, when cause and effect looks like a great thing. How could you ever violate cause and effect? And so cause and effect seems to suggest there's an intention. Something, wants to do something, and that can, get everything to end up falling into place. What a cause motion. At some level, you go back and you find what is the ultimate intent in getting the universe to move. But when you look deeply at physics, what you start to realize is that intention completely disappears from the picture. Right? Intention emerges as a good way of describing the world. But again, we have no intuition about why time emerges in this weird way from physics. And there's no unique statement about things about the error of time having to go from past to future. Right? That emerges in some statistical sense, which we can go into more depth. But the point is you don't really want to think, if you're thinking fundamentally, about intentions. And so you can think of this causing that, or you can just flip them around and say that the other thing is the effect is the cause. These are just words. Again, you get at words that are not terribly meaningful. They can be useful to some extent, but again, the intention is just make a statement, a blanket statement like that. We need to find the ultimate intent behind the universe. That sounded like a good idea, but ultimately there's no reason to expect that it's getting at truth.
What you just said is just another nail in the coffin of the apologist approach to this conversation. There was this guy that we're gonna go and examine in the next following shows who is famous for talking about the Kalam argument and how we've seen everything have a cause, and therefore the universe must be caused, and that seems reasonable until you actually look at what the science actually says and you realize that that's all bullshit, and none of that is actually accurate.
Yeah, you can certainly agree that certain ideas seem reasonable. That's fine, but that doesn't mean that they're likely to be true.
Right. Shifting gears for a minute, because we talked about this a little bit earlier, and you don't have to go into that much depth with it, but I was just curious to see how you would respond to what they're calling the replication crisis. Because often from theists, as an attack on my worldview, they'll approach it that way. They'll say, well, there is this replication crisis in experiments, and it sort of undermines any kind of objectivity that you can think you have in science. And I would just like you to clarify.
Yeah, I haven't heard of this kind of thing in physics at all, but apparently it's something that affects biology or medicine, something like that. And I don't think there's anything terribly deep to say about this. If it's true that you can't replicate experiments, then whatever those experiments are saying, you can't bring them into a theory. Right?
So
Theories are things that are supported by evidence. Many people have to do certain experiments, and things need to be borne out from those experiments. Gravity behaves in a very specific way. You have to do this in New York, you have to do it in Paris, and they have to all give the same results. Otherwise, it doesn't become a theory.
So the idea that this crisis is sort of spreading throughout all types of experiments in science as a whole is a false analogy.
Blanket statement. I mean, in my field, there are so many observations, and the observations are improving because with improvements in our technology, we're seeing things that it's hard for me to even imagine how we can detect radiation from the centers of galaxies that are so far away that it's hard to it just boggles the mind, right? And so I have plenty of data to work on and try to explain.
So in other words, they're taking something out of context and making it way worse than it actually is.
I don't. There's no problem with doing experiments in astronomy, astrophysics, cosmology. We've just spent in the it's 100 years ago. We didn't know whether our galaxy was the entire universe or not. People were debating in 1920. Right? They hadn't even started to debate this in detail. It was in the 1920s that they had a major debate about whether or not there were other galaxies. So the progress over the past 100 years has been enormous. We know also cosmology wasn't even a science until just a few decades ago. Now we've made such progress in understanding our level of ignorance about the universe. Right? We can put numbers on what we don't understand about the universe. Right? We understand 4% of the universe. And the other parts that we don't understand, the other 96%, we can divide up into some 73% that has to behave like this, but we don't know what it is. And the rest has to behave like that, but no one's ever seen it.
So yeah, my next question is sort of a two-parter. The first is, how do you respond to those who claim that science has nothing to say about the question of morality? The fact that we have so many cultures who have different notions of well-being makes morality relative and cannot be grounded by a physicalist approach. Now I'll ask the second part after.
I remember having this conversation with our father years ago when I was in my early 20s, and discovering, to my surprise, that there are people who spend a lot of their time thinking about ideas, professional thinkers, philosophers, even scientists, who are convinced along the lines that you just described. And I have to say, I was completely blindsided by this. It seemed to me just natural, obvious, right, that given that we are certain kinds of creatures. There are clearly things that are good for us and things that are bad for us. And then there could be a range of things, because we're complex. There's a range of things that are good for us and that are bad for us. But none of that complication ultimately changes the basic facts, and these are scientific facts, to be discovered to some extent, that certain things are good for us and certain things are bad for us. And so morality is basically just trying to get people to have the things that make their lives better in some objective sense, and not the things that make them worse. Now, those can be pretty broad terms, right? It's not that you have to want to go for a run every day for your life to be better, even though I think that makes my life better. Like, that's not what I mean. It's a very elastic kind of term. We're complex creatures. But I think that complexity somehow hides or gives the impression that it's just all up for grabs, that whatever your opinion is. I don't see that at all.
And it's ironic that they'll say things like, all these cultures have had different definitions of well-being, so how can we ground it in something objective? While there are thousands of denominations that say different things about what they think their God is and what the nature of God is, yet they are certain that they have the true version of this idea, and they somehow completely
It's
don't apply the
strange
same.
that when it comes to cultures, it's like you can be wrong about some scientific idea, but when it comes to culture, somehow everyone's idea or everyone's prescriptions are all right.
It really
Why
doesn't make
can't
any
we
sense.
just admit that some ideas are worse,
And
other ideas are better? I
an
don't see
even
why there
worse
can't be an objective space there.
an even worse approach is when they'll ask, well, is good goodness, like, or is good, how would I say this? Can we call goodness good intrinsically? What do we mean? Like, because they seem to want to suggest that we're making a value judgment by even calling good good and bad bad. So why should we care about
These are
what the
things to be discovered. Once we discover more about we discover some things about human beings. So, yeah, we know that, if you want to have a pleasant afternoon, don't jump out the window from 10 stories high, because you're going to smash your face, and that's not going to be a pleasant afternoon. We know that, right? But there could be subtleties, things to learn about what's part of this good and what's part of this bad, right? What's part of these words? There can be some subtleties there. In fact, there certainly are, right? We don't know. We know that we do things that make us miserable, right? Like, we have a sweet tooth. I know that if I stuff myself with ice cream, I'm going to feel sick and I'm going to be miserable and annoyed with myself. But I still have the pressure to do that. But we can understand that, by the way, for
sure,
biological
right?
reasons, right? From where we come from, we have these instincts. So we know that we have instincts that are not they're going to make us miserable, and we shouldn't give in to them. And there are a lot
And
of things that we don't know, but I don't see why isn't this still a space of objective statements, facts?
it's a dishonest move to say, to ask the question, is misery bad and is well-being good? Because it's failing to understand the role of language as
Yeah,
descriptions of phenomenological truth. These words don't appear from nowhere. They're reflective of, you know, intrinsically the content of experience is what it is.
again,
Then we apply the
a
symbols
lot of
bad and
these
good.
things can be need to be looked at in a flexible way. You know, falling and getting hurt, is that bad? Well, in a lot of ways in our lives, falling and getting hurt is a way to learn how to get by better, right? So that kind of thing doesn't stop the space from being a space of objective truth.
Right. There's some context, but
Yeah, there's a certain kind of elasticity. It can be complicated. That doesn't mean it doesn't lend itself to scientific ideas, science.
yeah, I always thought that it was just the question of is bad bad. It was just the most ridiculous pseudo philosophical in bad faith, misunderstanding
I
of
mean,
language.
it's a waste of time, it seems to me. If we have to spend our time discussing whether or not, jumping out of a 10-story window is bad or is it good, we're not going to get.
You're just ignoring reality.
Yeah, you're not really paying attention to what we're getting at.
Yeah,
You're just playing a game of words.
right, exactly. Yeah, we're gonna be going over a lot of that on our channel. Is what these games of words are, and how to sort of source through them and expose them for what they are. That's a big part of the reason why I'm doing this. Let me see if
Yeah,
I
I mean,
have any
I'm
other.
a firm believer in the idea of truth
Right.
everywhere. Whether we can get there or not is a different story.
Um, the last question I have for you, and then we can see if Mike had any more for you. We've had an ongoing conversation about this. Um, and for those who don't know, David and I are actually brothers. And a lot of my understanding about and my development in the way that I see things has come from observing conversations between my brother and our father, who, he did philosophy. Obviously, you're in the scientific field. And, you and I are, believe very similarly on many issues. But the one thing that I think we differ is on the notion of, you've described it as everything. How to say this? Both of us reject dualism, but while I tend to see things in the context of everything having to be physical, you have explained it as everything is actually mental. Everything is one thing, and the one thing you've described as mental. And I'd be curious to hear your explanation for that again.
Yeah, I think ultimately the problem is that we look at the world and we divide the world up into things that we'll eventually discover at a fundamental level to not be the right way. And
Right.
all I'm appealing to is this idea from physics, which is that the deeper you look, the more what you find is that things that seem different are really the same. And so, if that, I mean, this is sort of an intuition or a personal preference. Again, it might not be true. Again, I have no real right, but it seems like a good pattern. And if you take that pattern to its extreme, what it ultimately says is that you can't divide the world up into two completely different kinds of things. That's just an
Right.
appearance, but ultimately, fundamentally, they have to be the same. And when I say it's mental, it's because I don't really understand what it would mean. It seems like the mental is something that's very different from what the physical is in this dualistic picture. And so it seems like saying that everything is mental is a little bit easier. But ultimately, I
Right.
don't really know what it is that I'm saying at a fundamental level. I'm
Right.
just following that pattern. Of course, it's starting to become, metaphysics.
Right. Right. Yeah. I think I'm completely on board with you as far as everything having to be one type. Dualism, I think, is a complete failure philosophically and certainly scientifically. But to me, intuitively makes more sense to me to view everything, including consciousness, as being physical. And although you said to me that you know we haven't been able to explain consciousness in terms of purely a physical description of it. I wonder if it's just something that's eventually science is going to figure out, or if you can't
That's
figure
the
out,
position that, in fact, most people, I think, I would say,
and maybe if you
as far as
can't
I
figure it
understand.
out, my other thing is it may be a linguistic limitation. It may be a linguistic problem where because we have the subjective limitations that we have, and because there's a gap between language and the thing itself, no physical description is ever going to be enough to fully capture reality. But I don't think that means that therefore we should sort of flip it around and say that the physical aspect is the illusion, and everything is.
I don't think I'm saying one's an illusion. I'm not sure that that's one just gets subsumed by the other when you look more fundamentally. I'm not sure that you're saying it's an illusion.
Right. Maybe we're just
maybe we just haven't quite we haven't really honed in on the right terms to have this conversation. Maybe.
Right. Well, yeah, I think for now, that's all I can think of. Mike, if you have anything.
Well, you hit up on a lot of the questions that I had. I had the ones that I wanted to with the deterministic kind of or non-deterministic nature of quantum physics. But there's like I guess the last question I had was in reference to what you're talking about, and I pretty much at a point where I'm pretty confident to say I'm like a reductionist in the sense where I do think it can be boiled down strictly to the physical, and I'm not trying to. We've had this conversation, see. So it's not that I don't think like qualia doesn't exist necessarily, but I think that qualia can be explained simply by the unique, millions and millions of different variations that our brains can differently be comprised of, and physical senses in every way. So I think that would explain different subjective experiences that people have, or what people in philosophy might call qualia, and which is why it's different. But I do have a problem. It definitely is one of those things where it's like, well, how do you, define the experience of having the qualia, just in your own subjective sense and things like that. So I guess I'm interested on what you think. Like, are you familiar with qualia, and would you? You're not so like a sense. Cease might probably be better to be able to explain it since you're the actual philosophy student. But
well, David, the qualia is a term that basically is referring to what it's like, the quality of experience. So while I'm a reductionist, or I'm a physicalist as well, I would define myself as a non-reductive physicalist, because I actually don't think that it's possible to reduce qualia to a purely physical description. Because what I said earlier, there's a distance between language and phenomena that is not fully bridged, even though we can get close to it. There's no description of, cold temperature that I can give somebody that's going to make them understand if they've never had the experience of feeling cold before. That's what we mean by qualia. And
I think this is part of why I have trouble with saying that it's the physical part of dualism that's more fundamental, because you can't get the other part.
Right.
Whereas it seems like there's an easier way of getting the other part.
Well, I mean,
quantum physics is it's a very different kind of thing. Exactly like you said, you can't describe temperature. You can give the equations for temperature. It's the kinetic energy of particles. But how is that going to give you the sense?
But what if when we look through what is it, an fMRI, and we look at these and we see these brain states light up when the person is having the qualia? Would you say that wouldn't be indicative of, at least, I'm not saying absolute evidence or sufficient evidence, but I mean, don't you think that lends some credit to the aspect of it being able to be reduced, since you are witnessing the states within the
But I'm not saying that you can't look at. I'm not saying that if you think of, if you get rid of the dualistic picture, that there's nothing. You still have very rigorous patterns in this worldview, which you call it the mental.
Sure.
But it has to lend itself to these very rigorous patterns that we observe. It's somewhat difficult, somewhat abstract conversation. Again, I don't think we have the words to describe this, but
sure.
It's not like everything goes just because now somehow consciousness is the fundamental thing. Whatever consciousness is, it has to lend itself to thought processes that give way to these very rigorous patterns that we've discovered through science, right?
Sure.
Mike,
sorry.
No, I was just gonna say, sort of to respond to what you said.
Yeah.
Yeah, of course, you're gonna have physical description that you can apply, but it's never gonna be complete because we're not looking at consciousness when we're looking at our brain necessarily. In
Right,
that,
right. You're
because
looking,
Sure.
we're
you're getting
operating.
evidence that
Well,
different
it's because
parts of the brain are involved, right?
But
but it's
isn't
also
that
because
the
we're operating through consciousness. So we can make an object of the mode in which we're operating in the first place. It's like driving a car and saying that we can see outside of the car at the same time.
yeah?
I don't think that suggests that there is something that the physical should be described as something else. I just think that the problem for me is resolved when you look at it in terms of the limitations of language and the limitations of subjectivity.
I
When you
I agree.
conclude
Yeah,
those
I
two
agree with that.
things,
Yeah.
then it's like, okay, well, this is why it seems as though something is left over, because we can't get underneath that gap, and we're never going to get underneath that gap. But to me, that's just a limitation as opposed to something that
Why?
points to.
Okay.
Well,
Sorry, what were you going to say?
yeah, David.
No, I'm just saying, I'm not sure why there's a hard problem, and then you seem to conclude that we just can't get beyond the barrier.
Yeah, I don't think we can. Right. Yeah, that would be my response. I don't either I'm wrong about how I've described things.
But why can't
And
you just be wrong or to some extent confused by the fact that words produce a certain kind of mental structure for you? You see the world and you can't get past that. But you could imagine being more creative and in a more creative state, getting past that in some way. But isn't that really what science is doing? It's developing tools to get behind our intuitions.
I mean,
And our
that may be the case. That may be true. I currently have not been able to sort of get past that intuition. I mean, I can't even conceive of what it would mean for something to be no as I've described it. Now, it may be that in time, with more philosophy and more science coming in, that will shift my understanding. But currently, it just doesn't make sense to me. And I recognize that I'm at this point in time in a minority in the way in which I think about these issues. At least in my department, most people are not non-reductive physicalists. I mean, my professor, in fact, when I took philosophy of mind, sort of talked about them very dismissively, in like 2 seconds. He said, there's this guy that seems to think this way, but it doesn't really make sense. And I literally, like in class, like, no, that's the right answer. That's the fucking right answer. And he just stared at me. He's like, well, okay, so Edna, he thinks that it was funny, but yeah.
Well, I would ask like you on that point, like I, when you say it can't be reduced, like you're saying it does not boil down strictly to the physical, or you're saying we just simply can never get past that. Like, is your position that it's not purely physical? I mean, what else would it? Because I guess my problem is that when you bring up language with it, which by the way, stay tuned in because even the hosts have disagreements on their physicalism. So it's an interesting concept. But I guess I'd be confused on what if we had a linguistic problem with the way that we observe and think of consciousness within the brain, and that not be the problem itself. I think that's a huge thing. People like I don't know if that's a Dennett position. I know he doesn't think qualia exists, right? He's more of a
which is insane to me.
yeah.
I think that's ridiculous.
Which I don't think I'm there. It's not that I don't think that qualia doesn't exist. I think that like these are kind of barriers by language. I just think that from a standpoint within science, I think we could eventually boil these things down to a smaller level. I mean, the question that I had for David was essentially like there's a hypothesis about quantum physics being involved with with consciousness, and I don't know if you've heard anything in that regard. I'm not really as familiar with what that even really means, but
that's part of what people mean when they talk about the observer effect.
Sure. Okay. Yeah. Sure.
You need a conscious observer to collapse the wave function.
Yeah.
But that's no longer part of science. It really never was. Some people were thinking about it when quantum mechanics was being developed. And in one interpretation of the theory, we still have an unresolved issue, which is how do wave functions collapse if they collapse?
Mm-hmm.
Right? And in other versions, they don't collapse.
Sure.
So if you take a course in quantum physics, the course that I'm teaching, there's no collapse of the wave function in the theory. You look at the math never. You get the wave function, and the wave function is what it is, period. And then you're told that if you make an experiment, you'll get one of these outcomes that's in this wave function. And then the state has changed. In other words, it's collapsed to what it was before to something else. That transition isn't in the theory. There's no mathematical, you can't put a time into the mathematics and find collapse. This is such an abstract process, by the way, that a lot of people who practice physics, that do quantum physics, don't realize this. Right? So I actually had a debate when I was teaching at Columbia University with a particle physicist who thought that in the wave function, the solution to the Schrodinger equation, you at some time you put a certain time in t equals 5 seconds or 5 hours or whatever, and the wave function collapses. It just dramatically changes because you're always told that wave functions collapse. It's not there in the theory, so there's still an unresolved problem in this version or interpretation of the theory that involves wave function collapse. How does this happen? It's not in the theory. You have to add something, and I haven't heard an explanation as to how this happens. There's a lot of confusion there because Einstein said certain things and people confuse this issue with how the wave function collapses to what Einstein was saying, and they're completely separate things, and it's become kind of a mess even for people who work in the field.
Sure.
People who are not dealing with foundations of quantum physics, they get this all confused. People who use quantum physics to do their experiments, make predictions, they don't understand the foundations, and so they get these things all confused.
Yeah, in my field, I run into similar things where people have entirely different interpretations of the same philosophy. They think that one guy is saying something, and another guy thinks they're saying something entirely different.
This is not even a question of a wrong interpretation. This is just a wrong assumption about a theory.
Sure.
Right. No, I would say the same thing about things I've dealt with, like especially for example Nietzsche. The amount of times that I fought with my professor about how we understood what he was saying, because I said, what you were claiming is not found in the books. In fact, here is the opposite of what you're saying.
Right. Yeah.
And yeah, it can be very frustrating.
Sure. Yeah. Yeah. Cease, do you have any more questions before we wrap up? I think that was definitely a productive one. I'd like to have him on more. Maybe we can get into that consciousness thing.
Yeah, David, thank you so much for coming.
Thank you guys. It was a lot of fun.
Yeah.
I think it's a little over an hour, about an hour or so. That's good enough.
Yeah.
That's about it. That's my stamina.
That's yeah. I understand. Yeah, it's my stamina for about the next meal I need. So I feel you there.
I can do this all day.
Yeah.
No, I can't. I start to fall apart after about an hour and a half, I think.
Yeah.
But yeah, we'll definitely have you back, and yeah, we'll talk soon.
All right. Thank you, guys.
Thank you.
Right.
And thank you everybody that's tuned in. We will hopefully we'll have the next episode should be either me, Max, and Cease, or me and Cease breaking down some clips, maybe some William Lane Craig clips. There's one in particular that I really want Cease to break down with me, and then if we don't end up doing that, it will probably be David Gonzalez, a friend of ours that we've met online, who is a Christian. I wouldn't say apologist, but he definitely is an activist.
He's on his way.
He's getting there, yeah. So that'll be fun, and we'll see you guys then. So peace out.
Okay.